Okay, so now we are trying to go into problem 2.5 and okay, so this is the figure from the problem, and the problem says a steel tank is to be positioned in an excavation. Knowing that alpha equals 20, so we know that alpha equals 20. Determine by trigonometry, and as we mentioned previously, for us we'll not really be using this method. Anyway, A, the required magnitude of the force P if the resultant R of the two forces applied at A is to be vertical. And clearly it will be upwards, right? B, the corresponding magnitude of R. So let's first go with A. So for A, we're trying to find the required magnitude of the force P if the resultant R of the two forces applied at A is to be vertical. So that basically means that, and this is very easy to do, like we might not even need to use whatever we have. So let's import SymPy. Similar to what we did here, look. Let's go back to our go to problem 2. So in problem 2.2, what did we do? Equation solve. So let's import this. Import numpy as in P. Yes. And let's go for, look, this is very easy, right? Because let's define P, just like the force P, and we don't even need to define it as a force. Yes, symbol P, and then equation, let's say that, so 425 times numpy cosine radians 30, right, minus P times alpha. And then solve here. Oh, but this is 20. So we can basically see that P, force P, is equal to 391.682. And if we go to our first, now this is very simple because it's very similar to our first problem, right? Now we just want to get this. And then we can define both our forces and get the resultants. We will adjust it, of course. Let's actually call this one Q just. So it will be 425. And the direction will be... So what the direction will be? 180 minus 30. Right? Because we're always taking the angle from the positive x-axis counterclockwise. And this one will be 20. And the magnitude, we just got it here. It will, and we can easily get the resultant. And the reason it's actually giving, it shouldn't really be giving negative, but it's given us negative 90 degrees, which would mean it will be down. But the reason is because we are getting the arctan here, and the tan will be infinity for both positive and negative, right? So I'm pretty sure there is a better way to do it. However, for now, let's just stick with using our own sense with the results that we get. And actually, this is a very important point, that you do need to use your senses, or to use your judgment to judge the results that you are obtaining from any computer program, right? But anyway, we know that our resultant is 364.46, and that the direction will be positive 90, because it should be it should be 90. But based on the equation that we used, it will not always give the right value. Actually, I would like to point out something else. If instead of just substituting the first, the value up to the third digit after the, up to the third digit here, we substitute the whole value, look, we will get closer and closer to the 90. And the summation of Qx and Qp will get closer and closer to 0, but it still will be just a little bit of the 0. So actually, let's make this adjustment right now so that our algorithm can perform better. So basically from here, if our Rx is less than, and for now let's just put the threshold based on our own judgment, is less than 0, and let's actually do it, if the absolute value of our Rx, because it might go negative or positive, is less than 0.01, then let's say that if Ry is more than 0, alpha equals to 90, actually say else alpha equals negative 90. And we might be facing some problems later if, for example, like our angle is more than 360. Or there we might have, or like, or if it's 270, right? Which is like the same as minus 90. But for now, this is a temporary solution. So let's see. Actually, this should be else. Oh no, actually, else. This is correct. And then this else for this one. Else we will go with whatever we had before, and then we will return this. Oh, I just saved. Okay. Okay, so let's do this, and if we calculate it, that will be exactly what we are expecting. So our degrees, in degrees, we will have 90, the resultant. Of course, we know that it's like our assumption was made so that it is vertical, the resultant is vertical. But this is how we fixed our current algorithm to account for that. We might need to adjust a lot of things in the future. However, just for now, this solution worked for us, right? So this is one way to think about it. Okay, thank you. And this was problem 2.5.